An equation that contains an absolute value is an absolute value equation. So some examples include the absolute value of x is equal to 2, the absolute value of 2x minus 1 equal to 5. Another example, the absolute value of 5 minus 3x minus 3 equal to 1. Those are all examples of absolute value equations. Let's consider the absolute value equation of absolute value of 2x equal to 4. This equation has two solutions, both negative 2 and positive 2, because the absolute value of 2 times negative 2 is the absolute value of negative 4, which is positive 4, and the absolute value of 2 times 2 is equal to 4. Just recall that absolute value gives you your distance from 0, so it's always going to be a positive number. And effectively, it gets rid of your negative sign. We can also demonstrate this result with tables and graphs. So, for instance, the absolute value of 2x equal to 4, I would pick some values for x and calculate the absolute value of 2x. So the absolute value of negative 2 is positive 4. For negative 1, it's positive 2. For 0, 0. For when x is 1, the absolute value is 2. And when x is 2, the absolute value is going to be 2 times 2, or 4. So you can see that x equals negative 2 and x equals positive 2 gives you that 4. Looking at the graph of the absolute value of x, absolute value of 2x, we see the x values are negative 2 and positive 2 as well. There are three cases to consider. So when you're dealing with the absolute value of x equal to k, if the k is positive, then the absolute value of x equal to k is going to be two answers. Either x is k or x is negative k. If k is 0, well, the absolute value of x equal to 0 only occurs if x is equal to 0. And if k is negative, then the absolute value of x equal to a negative number has no solution, because the absolute value is always positive and can never equal to a negative. So let's first solve the equation, the absolute value of 2x minus 3 equal to 7, graphically, and then try to solve this algebraically. So graphically, that's going to occur where the graph is, I graph the absolute value of 2x minus 3, and I graph the horizontal line y equals 7. And you see that they cross when x is 2 and when x is 5. So I know my answer should be negative 2 and x equals positive 5. Okay, so let's see if we can verify that. And the way you do that is you take this equation and break it into two different equations. We'll take the 2x minus 3 equal to 7, but 2x minus 3 equal to negative 7. And we solve each one separately. So for the first one, I add 3. I'll have 2x is equal to 10. And if I divide by 2, I'll have x equal to 5. Okay, that checks. That's that right one right here. For the other one, if I add 3, I'll have 2x equal to negative 4. And then if I divide by 2, I end up with x equal to negative 2. And that corresponds with the left one. So it matches. If my equation was the absolute value of 2x minus 3 equal to 0, well, you can see that graphically that occurs when x is 1.5. So graphically, the answer is x is 1.5. We look at the first number. We're comparing where that is where the y value is 0. Algebraically, 2x minus 3 equals 0 only occurs when 2x minus 3 is equal to 0. There's no plus or minus here, since minus 0 is the same thing as positive 0. Add 3, I'll have 2x is equal to 3, and then if I divide by 2, I have x equals 3 halves, or 1.5. So it checks either way. And in this case, if the absolute value of 2x minus 3 is equal to negative 2, you can see that I draw the line y equals negative 2, and I drew the graph of the absolute value of 2x minus 3. They don't cross. there is no solution in this case. And algebraically up, the absolute value is always positive. It can never equal to -2. There is no solution. Trying a couple others. If the absolute value of x is equal to 0.003, then there's really no work involved here. It's 0.003 and x equal to -0.003. If I have 3x minus 2 is equal to 0, then that means that 3x minus 2 is equal to 0. So add 2. I have 3x is equal to 2. And then if I divide by 3, I'll have x equal to 2/3. If I have 10 minus x equal to -40, that's going to be no solution because the left-hand side is positive and the right-hand side is negative. There's no value that can make that happen. So no solution. And finally, x halves minus 1 equal to 11. I can break this up as x halves minus 1 equal to 11 and x halves minus 1 equal to -11. So I would add 1. So I had x over 2 is equal to 12 and then times both sides by 2. So I would have x equal to 12 times 2 is 24. Here I would add 1. So I have x over 2 is equal to -10. And then if I multiply by 2, I'll end up with x equal to -20. So my solutions here are 24 and -20.